Geometry Dash is a game with simple mechanics, right? Click, and that's it. So let's use the infinite monkey theorem and statistics to see if it's possible to beat stereo madness on your first attempt while clicking randomly. Now, let's set up a scenario to consider. We give an infinite number of monkeys a sale device and a computer that runs Geometry Dash. They are all blindfolded and know that they are meant to click. We want to know how many of them will successfully beat stereo madness by pure randomness. So, according to Google, stereo madness is 89 seconds long, and Geometry Dash runs on 240 FPS, so the total number of frames in the level is 240 times 89, which is 21,360 frames. 1,360 individual moments where a click could happen, and every single frame is a decision point for the monkey. Click or don't click. So each monkey generates its own sequence of 21,360 binary digits. So if each frame has two possibilities, click or don't click, there are 2 to the power of 21,360 different click patterns. So if we consider the most brutal scenario where every single jump is a frame perfect, where if an extra click is a death or one misclick is a death, there's only one winning input pattern. So out of the total 2 to the power of 21,360 different click patterns, there's only one output, which is successful. So the probability is 1 in 2 to 21,360. Now to put this into perspective, the observable universe contains 10 to the power of 80 atoms. Our probability is 1 in 10 to the power of 6,349 times smaller than if you picked one specific atom in the entire universe at random. So if every single atom in the universe had its own monkey, they still wouldn't be able to successfully beat the level at random. But this is a very unfair calculation, as not every single click in stereo madness is a frame perfect, so we need to be more lenient. So let's consider a new model, spam model, where we remove the frame perfect restriction, and so the monkeys are allowed to spam and click whenever they want, just that they have to click on the required minimum of 77 frames. So the probability becomes the probability of each click being correct, so 0.5 click or not click to the power of 77 correct frames, which is about 1 in 10 to the power of 23, which is about Avogadro's constant, which is 6.02 times 10 to the 23. So if each mole has 6.02 times 10 to the 23 molecules in it of that substance, then if every single molecule in the one mole has its own monkey, at least one monkey will be able to beat stereo madness per mole. So this is much more likely than the previous 10 to the power of 6,000. So for a reference of scale, a cup of water has 13.9 moles. So that means out of all of the molecules and all of the different moles in the cup of water, at least 13.9 monkeys will be able to beat stereo madness. And this is per cup of water. But again, we have another problem with this model of spamming. This means that the monkeys could spam at any time, and that means they could spam early and click a spike, and that means they'd die, so they would have lost. And they could click way too late and they just jump into a gap and die. And so we want to eliminate all of these other wrong scenarios. It would just bring us straight back circle and give us another number, which is approximately 10 to the 6,429. And so we arrived at our answer. There's a probability of 1 in 2 to the power of 21,360 or 10 to the 6,429 chance, which is 6,000 magnitude to 10 larger than the number of atoms in the universe. So theoretically, with an infinite number of monkeys, mathematically, there would be some cases of success. However, this is physically impossible in our universe and would never happen. So unfortunately, the answer to the question, can a blindfolded monkey beat stereo madness,